Let me utilize the code that I wrote last time to make sure that I don't goof it up. So we're going to do a couple of things. We're going to use a library that we haven't used before, excuse me, in order to get the functionality to open a port to try to establish a connection with it. And then we're going to use try-catch blocks, try-except blocks in order to capture any errors that occur. And we'll first do it without that try-except block just to see what happens, and then we'll note that when it can establish a connection that there are times when it can throw an error. And even if we don't see it, then we'll go ahead and put it in there anyways. They're called try-catch in other languages, so sometimes I mess up and say that when in this language it's called try-except. It's called try-except because what happens is the program that's running, when it's about to crash, it generates what's known as an exception. And you've seen that little message down there in red text at the bottom of your program when you run it. I expect somebody would tell me if we've already done this lecture. No? Good. Alrighty. So we're apparently on lecture elemental PQR, looks like. I think what we're going to be doing is port scanner and file I/O. Trying to finish up the chapter. Maybe we already did finish the chapter. Did we talk about checking to see if files exist on Thursday? Yeah, okay, so we may already be done with the chapter and ready to go on to the next one. So this is going to be a port scanner, and then we'll move on to the next chapter. Okay, so we need a machine to scan. And the way we're going to determine which machine we're going to scan is, well, you know that like if you type in www.ibm.com, then that has to be turned into a series of numeric values in order to be accessed off the internet. And that is done via what's known as a name server, right? I want to know the IP address of rose.com. I ask the name server, it tells me the IP address, and then I can establish that connection. And if the name server is down, then it's going to be much more difficult for you to access that server. There is a file called hosts, or hosts.txt, that you can configure on your own machine where you can put IP addresses in that don't exist on the name server. But then the problem becomes, what if those IP addresses change, right? Somebody moves that machine to a new location. In that case, you would have to go and edit your hosts.txt file to make it correct. And the idea behind name servers is it's a global network, and you make a change in one and it's supposed to propagate to everybody. That's also kind of a problem because people can make malicious changes to name servers, and they try to verify that that's not the case. But, bringing YouTube down for the entire, continent of India or whatever because somebody, made malicious changes to redirect the YouTube URLs to somewhere else. But anyways, we need that IP address, and you know what an IP address looks like. Don't type this up. It looks something like that. It's a series of 4 bytes. Each one of these can be, the value is 0 to 255. Now it's 4 bytes if you're using something known as IP4. IP6 has a lot more bytes, maybe 8 or something like that, because pretty much the world has actually run out of IP addresses. It's only through the miracle of a lot of complex routing tricks that people can still add new machines to the internet. So, when this kind of stuff was invented, there were like 13 colleges and military sites and, institutes like that on the internet. And then, there were like, 100 and 200 or whatever. And these, various number of bytes here, if you have 4 bytes equal to the power of, 255 different choices or whatever. Okay, I've obviously done that wrong. I meant to do to the power of. Alrighty, that's a lot of different machines. We ought to be able to make do with 4 billion different IP addresses. However, there are a lot of things out on the internet, and so this has pretty much been used up. If you go and look up, IP4 limits, usage, used up. All right, This time it's for real. The last available IP4 address block is gone. And so changing to IP6 is one where you have IP addresses that are much longer, where you have 8 bytes involved, I believe, rather than 4, and opens up, zillions upon zillions upon zillions of IP addresses. But unfortunately, not every machine on the internet supports IP6, right? The cards have to support it, and the routers and hubs that you're attached to have to support it, and all that stuff. Well, anyways, we want to get our IP4 address of a particular machine. Let's look up rose.edu. We need his IP address. I'm going to call this SN for server name. Server name is equal to rose.edu. Now we need to import the socket library. So really that should be above that line. Import socket. And if we go to the Python shell, we can do dir. Well, let's import it first. Import socket, and then we can do help or dir socket, and it'll show us a list of all the functions that are attached to the socket class. A bunch of them. Check to see if it has IP version 6. Be interesting to find out if rose.edu accepts IP6 as well as IP4. Get host by address. Get host by name. We're going to be using one of those to get the IP address out. So let's get the address based on that. Address equals, and this is going to be a lot of typing, so we might make typos. Socket dot, and this is all lowercase, get host by name, get host by name, parentheses, SN for server name. And let's just print the server name and the address out just for giggles. Test it, make sure that we're not getting errors at this point. All right, I believe it. 52.4.133.208. Now, if we put in here, I believe, localhost, it should come out to 127.0.0.1. That's the loopback address. That's your own machine. If you're going to be establishing a connection with a service, a port on your own machine, you ought to be able to use either that name or that IP address. I'm going to leave it as localhost right now. Go back to playing with rose.edu later. Hope I don't get in trouble for encouraging our class to port scan our web server. So we have an IP address. What happens if we feed in something that doesn't exist? There. All right. We got an exception. Right. So really I should put that in a try-catch block and cause the program to fail. I mean, prompt them for a new address or print a graceful error message or whatever. And we're going to be really, really lazy and not do that. But for the next part of the connection, we won't be so lazy. Okay. So 2 ports that I've changed my mind. I'm going to change this back to rose.edu. 2 ports that I'm really sure that rose.edu has, and I'm just going to make a capital L, but I really should call it like something like port list or ports, is 80, which stands for HTML, HTTP, and 443, which stands for the secure version of HTTP. And now you've noticed, probably over the years, that when you connect with something, usually it's using HTTPS. And the reason for that is that somebody with a port scanner could see the content of the communication when you're making requests to that server. But if it's HTTPS, you can't see the contents of that request. And so it gives you more security. So nowadays browsers are flagging HTTP communication as being non-secure. Newer browsers may display a little warning to that effect. A lot of these things still support HTTP, but a lot of them also immediately redirect them to HTTPS. So we're going to be checking for those 2 ports, see if they exist. Now we should write the next thing as a function. And we haven't done a lot of functions, so I don't think that that's a bad idea to do. So I'm going to come up here to under import socket and write a function called try-port, something like that. DEF try-port, not try-post. I keep typing post. Maybe try underscore port. I like underscores. I'm old school. So what are we going to do? This thing needs two pieces of information. One is it needs an IP address, and the other is it needs to port to try. So IP, comma, and then port. Those are going to be the two parameters that we're passing to our function. Excuse me, those are the two parameter variables, and we're going to be passing into arguments to fill them in. So the first thing we're going to do is we're going to create something that's called a tuple. We've seen a tuple in the past, but it was kind of hidden. And don't type this, but when I did this, %D, and then I did that, and then I put two things, you know, inside the parentheses. This is what's called a tuple. It looks like a list, but it's not a list. It's ordered, but you can't change the values of them. I don't know that that's strictly true if you can change the values. Anyways, so the way you create a tuple, and again, don't type this, is with parentheses rather than square braces, and then you can access each element separately. You can say, okay, a subscript 0, print that out, and it's equal to 100. A subscript 1, it's equal to 200, just like you can with any other list. We're going to create a tuple based on the IP and the port. I'm just going to give a really lame name, and stick those two pieces of information in a tuple. And the only reason I'm doing that is because the function that we're going to be calling is expecting a tuple. I hope I'm not completely wrong about that, because if I am, then that's a completely useless way of doing it. No, I'm correct. Alrighty, we may as well print what we're trying to open. Here, print trying port, end quote, plus A, like that. Now I want to keep this program in a working state, even if it doesn't do a darn thing. And what I mean is, I want to set it up so that it calls this function, so that I'm sure that the function doesn't have a syntax error in it. So what I'm going to do is I'm going to come down here and I'm going to write the for loop that is going to call this function, even though the function doesn't do anything yet. So what are we going to do? We're going to step through these ports, the port list, with a for loop. For P, or PT, for port, in ports, for variable in the list, we're going to do result equals try underscore port, and we're going to try the address followed by that port. Good enough for now. This should at least let me test it, make sure that my syntax is good. Like I said, it's not doing a darn thing, it's just doing print messages. That's okay. Trying port. It must be a string, not a tuple. Alright. That's because I momentarily slipped into Java, where you separate things with plus signs. Change that to a colon on that line. Alright. And we're pretending that we're trying those two ports. The reason I do that is so that as I make changes, I can keep running it over and over rather than write 200 lines of code and then have it work. And if anybody's got a syntax error already, then it'd be a good time for me to wander around and help y'all with it. Alrighty. So here's what this really needs to do. It's not just print trying. Is it actually needs to try to establish a socket connection to it. So sock, variable name doesn't matter, is equal to socket.socket. In other words, make a new socket. And we saw this syntax if we ever created a turtle. Turtle.turtle. except I believe that turtle was capitalized and this one's not. And then we're going to type some gobbledygook that we don't really know what it means unless we're network specialists. Socket dot, and then the next part of this is all in caps. AF underscore INET, AF underscore INET, comma. I'm going to go to the next line, but you don't need to. Socket dot, and then the rest of this is in caps. Sock underscore stream, parentheses, colon. No, wait, no colon. It's not an if or a while or def. And then we're going to try to connect to that socket. I'm going to put a comment here saying that I know in advance that we're going to have to enclose this in a try-catch block, but I'm not going to yet. And then we'll go back and we'll fix that. So the result is equal to sock.connect underscore EX subscript A. And so the address we're trying is the one that we stored in a tuple up here. If we had not stored it in a tuple up here, then the syntax, and don't type this, would look like this. That's kind of alien looking to us, right? Maybe you dig it. What it's saying is create a tuple and then pass it in as a parameter to the sock.connect method. But I'm going to leave it like it was, because to me that looks a little bit better. And then if the result is good, if result is equal to 0, then we can, and you know what? I think I'm not going to even put the message there, because we can put that down below when we call the function. So what we're going to do is then we're going to return the result. And this function here, what its return value is, and we could do a help on it if we wanted to, return 0 if successful. So that's what this function is going to need to return, is a 0 if it's successful. If we encounter an error, if we do the try-catch business. Maybe we don't have to add the try-catch business. Let's see if this works without it. Well, those are two good actual valid ports, so it didn't need it. But what happens if we type in a port that I know is not open? 79, whatever port 79 is supposed to be. Well, it hung there, but that's okay. It didn't crash. That's cool. It could be that the only thing that actually crashes is the lookup by host name, like if we try to look up that. What if we try to access a IP address that doesn't exist? I'm going to change this temporarily. Don't make this change. Like, what if this IP address was 1.2.3.4? I kind of doubt that that exists. Oops. That needs to be a string, doesn't it? Like I said, don't make that change. This is for experimentation. I'm trying to break the code. See how it breaks. Okay. Get address info failed. Again, that was this line. No, it wasn't. Let me track the line number again. Line number 23. Is it because I changed it down here? Yeah. Let me undo that change. Run it again. All right. We're not getting exception errors there. The only place that we're getting exception errors is right here. This is the one that needs to be enclosed in a try-catch block. We haven't found anything that will cause this one to break. So I'm just going to delete that little comment there. And then I'm going to undo all the changes that I made. And when I say don't make this change, I really mean it, because I start flying around trying to figure out how to break the code. And then I change it back. All right, it tried port 79, it tried port 443. We don't know whether they worked or not. So down here, after we're done calling it, let's reduce a couple of blank lines. We can check the result. If result equals 0, colon, that's a success. Print SN, comma, address, comma, PT, short for port, comma, is open. Printing out all the information around it. We're printing out the server name, the address that's associated with it, the port number, and then we're printing out is open. And since I changed this to 79, a non-existent port, or one that I'm sure is not existing. All right, and so it says that is open. Now, if we set this to actually be a port scanner for a whole bunch of ports rather than just a couple, right? You know, if we try to, scan all 2,000 ports or something like that in the first 2,000, then I don't know that I want to see that many messages. Maybe we ought to take this print statement out up here then. I'm going to comment that print statement out. And this would be a real good time for me to wander around and make sure that everybody's got it going. All right, so it tried that port, and again, I don't need to print that out, or at least I could make it a little bit more educational. Where are we printing that? We're printing that here. We could make it say host whatever is at IP address that. We ought to print out at least what we're going to be doing. So I'm going to modify this print statement here under get host by name. So name server reports %s at address %s, comma, no, not comma, end quote, %, parentheses, and then 2 close parentheses. That'll just make the output be a little more informative. The name server reports that rose.edu is at address 52.4.133.208. And then we start running it down, and we found one open port out of our 2. Right now it's not reporting errors. If we think it should report errors, which we probably want to do if we're just sequentially scanning, right? Then we would put that down in the if statement. So that's the statement that I just added, and this would be an excellent point for me to wander around and make sure that anybody who is following along has it going, because I've been making changes left and right or up and down. Alrighty. Well, that means I'm going to have to repeat the part about the dictionary, but we're not going to do that right now. What we have done is we have plunged into Chapter 5. And we were talking about the difference between lists and dictionaries. A list is just a sequence, right? L is equal to 1, 2, 4, 8, whatever. And then you access them by their index, by their subscript. L subscript 0 would print out a 1. L subscript 1 would print out a 2. L subscript 2 would print out a 4, and so on. But a dictionary is a series of keys and values. So you could say that L subscript Bob is equal to, what's his last name? I don't know. And that L subscript, Abe, for Abe Lincoln, is equal to Lincoln, and that kind of stuff. So if you want to get out the guy's last name, you just print out L subscript Abe, and you get Lincoln out of it. If you want the last name for Bob, you use L. So this is your key right there. And this is the value that's associated with it. So a list is a sequence. You could have a shopping list. You could have a to-do list. Your phone will have a list of MP3s installed on it. Your messaging app probably has, a list of all the current conversations that your, roster for an athletic team. A recipe, which is a list of instructions, names in a phone book, and so on. Each item has a unique index, starting at 0 and going to length -1. So if the list is 1,000 long, you can access subscript 0 up to subscript 999. So when an element is in an expression, its value is included in the list. This is interesting because they have made a list of lists. Kind of a weird idea. It works. Here's a simple list of fruit. So we need some list homework, and I hope that the folks who weren't here already know enough about lists based on our prior lectures that you can do this, but again, we will be reviewing some of these concepts on Thursday. So, list homework. 1. Write a loop that runs 10 times, that's a bit excessive, 5 times asking the user for a name and adding it to a list called names, adding each one to a list called names. Then print the contents of that list using this syntax. For S in names, colon, print S, comma, END equals, quote, space, end quote, and then after the for loop, we're going to just print a character turn. I'm going to go to the next line. So for that to work, your list better match that name, right? If you change the list name, you just change that syntax. S is not a magical value. It's just the variable name that I arbitrarily chose. A lot of times you'll see people do this. For every name in the names, right, I've already made the mistake, right? That's why I don't recommend doing that. If you differentiate a variable just by whether it's single or plural or not, you're likely to goof it up. And that would print out the entire list each time. I don't want to do that. Okay, so that's one of them. And then, how do you add to a list? Here's how you add to a list. Let's create an empty list. L equals, that's our empty list. And let's add some values to it. L.add, parentheses, quote, 1, end quote, in parentheses. L.add, quote, 2, end quote, in parentheses. L.add, parentheses, quote, 3, end quote, in parentheses. Now let's print it out using this syntax, but let's also just print it out as a primitive list. Print L. Right, that'll be a primitives list, and we'll see the square braces and all that. And now we're going to print it out with a for loop. For S, oh wait, I wanted to change that back to what I recommend for S in names. For S in L colon, print parentheses S comma, END equals, quote, space, quote, in parentheses, and then underneath that, let's just put our print statement, blank line. Let's make sure we don't have any syntax errors at this point. It's not called add, it's called append. You walk out of a Java class, your brain fails a little bit. Change all of these adds to append. And here it printed it in primitive list format, right? It actually let the list object create its own representation. And here's how we printed it. And I hope you all understand the function of that end thing, because every time you print something, it goes to the next line. You know, and I can stick anything I wanted in here. I can put 2 question marks, and then when I run it, it's going to print out question marks. You know, that was its end character. By default, the end character is equal to this, \n. That's what it defaults to. Yeah, but we don't want the default. We want spaces. Now, it'd be even cooler if it put commas between it, but it didn't put a comma at the very end. You could do that with a join function. I'll demonstrate it to you, but you don't got to do this. Print, parentheses, quote, what are we going to separate everything by? A colon. Quote, end quote, quote, colon, end quote, comma, join, and I want to join that list using that as my delimiter. And there it did it. It printed it all out separated by commas without putting a colon without putting a trailing one. That's a pretty nice syntax. But in this particular case, I want you to use the for loop. We'll probably use this one again in later, to speed things up in the future. Okay, so that's one of the homework. Print the contents of that list out. And then 3, create a list using a for loop where item 0, or that is just a list of the square values. That is a list of the squares of the numbers 1 through 9. In other words, let's give the list a name, squares. And so where squares subscript 0 is equal to 0, of course, square subscript 1 is equal to 1, square subscript 2 is equal to 4, square subscript 3 is equal to 9, all the way up to square subscript 9 being 81. Like that. But you're not going to declare it like that. Use a for loop and dot append to do that. And so we'll give an example. We'll give more examples that let you do this on Thursday. Could be that we've written enough, or it could be that you remember enough of this from fundamentals that you could whip this out, and that's great. If not, right. We're going to be covering more material as we go through the chapter. That'll let you do this. And for those of y'all watching at home, we spent some time talking about dictionaries as well. You might scroll up and look at the code, see how we did it, but we will be talking about it again when we hit it in the PowerPoint. All right, does that homework make sense? Hope so. I'm trying to make eye contact. All right, let's stop the recording and make a Dropbox for Lecture R.